when we have collected data and we are trying to look at the relationship between the two variables, the independent and the dependent, it is rarely the case that the data will fall on a straight line. We are usually satisfied with rough estimates, and that means that any kind of relation that is strong or even weak will be sufficient for us to derive some conclusions. So what we are looking for is the line of best fit, which is the line that best fits the trend of the data, and this is called the least squares line. And to do some examples, let's assume that we want to look at scuba divers and the relationship between the maximum dive time they cannot exceed and the depth that the dive is. The data in the table below shows depths with maximum dive times in minutes. So one thing that this table doesn't show us is the units for the y, that is the dive time. So let's remember to say that the units are minutes there. And we want to use the technology to find the least squares regression line and predict the maximum dive time for 110 feet. And you can see here that in the table we have the depth in feet from 50 to 100 and the maximum dive time at that depth from 80 at the shallower depths to 22 minutes at the larger depths. So we will use technology to find the line of best fit, and I will use Excel. So I have copied here the depth in feet and the maximum dive time in minutes, and I will highlight the titles and the data values and insert a scatter plot. And here, remember to add axis titles and to also fix your title so that it's a little better. You may also want to adjust the horizontal axis so that it doesn't start at 0 but it starts at 40 so that it looks a little better. Therefore you can see a little better the trend. It looks like it's a negative kind of strong trend. To get the line of best fit, you can either here from the plus add the trend line. So let's click here. The problem with that is that we want to have some more information about from the trend line. We would like for that line to always be linear, but we would also like to see the equation and we would like to see some more data, mathematical data. So the best way to do that is to actually right click on one of those dots and see that they are all selected. And from here add a trend line, and then the pane here on the right will open up for which you can actually select what you need. It defaults on a linear trend line and we are interested in a linear correlation, so we will leave it here. And we want to display the equation on the chart, so make sure you click this box here at the bottom right. And we also want to display the R squared value on the chart that we will use later in this chapter. I can now close all of these things and zoom in a little bit so that I can see my trend line. I can move this text box a little bit further away so that I can read it better. It tells me that the y is equal to negative 1.1143x plus 127.24. And for the R squared, we will use it later in this chapter. So here I'm going to go back in my notes and I'm going to write the equation. And to guess the maximum dive time for 110 feet, I will plug in x equal to 110 and guess the value for the y. Remember to always write y hat here. because this is an estimated y. The reason it is an estimated y is that none of these points are on the line of best fit. There is always a vertical distance between your real point and the actual point on the, the point on the line and the actual point in your data set. So another thing you want to notice is that this line is only sketched from the smaller x value, which is 50, to the largest x value, which is 100. So when you are guessing for 110, which is a little farther away from your data set, this line was not created for values farther away from your data set. So you should always guess with some level of caution. So I did guess when I plugged in that the maximum dive time for a depth of 110 feet would be approximately 4.7 minutes. That's when I did the math in my calculator or in Excel in some other way. So the next question would be, if I have a random sample of 11 statistics students, produced the following data that gives me the third exam score and the final exam score. Can we predict the final exam score of a random student if we know the third exam score? And again, it all depends on whether we do have a good and strong correlation to make a prediction. And here we think that we have a good correlation with the depths, but I also see that there is kind of a curvy trend. So it is possible that a linear correlation is not exactly perfect. But let's try to see if the third exam score and the final exam score produces a good line or some kind of relation that can give me confidence enough to make a prediction. So again, I'm going to highlight the titles and the data. I'm going to insert the scatter plot right here. Remember to add nice titles and axis labels. And I see here that it looks kind of a little flat. That is because the y-axis starts at 0. I would like my y-axis to maybe start at 100 so that I can see the slope a little bit. So let's press 100. There we go. Now you can see a little better that there is a positive relation. Is it strong? It doesn't seem very strong. These points don't seem like they are on the same line. So let's try to see what the trend line looks like. So if I right click on one of the points and I add a trend line, it defaults to linear, which is what I want. Display the equation, display the r squared for later, but for us to now already starting to see values. So this r squared was 0.9273. This r squared is a 0.4397. And I already see that there are more significant vertical differences from the point of my data to the corresponding point on the line that has the same x value. I see vertical differences that are more significant here. I also see vertical differences that are kind of close and some that are not very close. So there is bigger variability, and then it will be up to us as statisticians to decide if this line is a good line to make predictions. We will look at this line a little more in the next video, but for now, start thinking about how a particular set of data can create or help us make decisions about whether there is a strong correlation between the variables.